Great. Thank you, Ralph. So this is actually to be the last talk of this session. Let's move on to the third talk. Sorry about that. For Abed Ayyad, using NASA power data in R to model solar PV output globally.
Okay, hello everyone, and greetings from unusually sunny Vancouver. I will talk to you about power, which I've been using for the past few years, beginning from when I was in Utrecht in the Netherlands. I'm going to apologize a little bit because I think I underestimated the level of discussion, but the upside of that is that I'm just going to cut through this very quickly. And so I just wanted to talk, if we could just go on to the next slide. Basically how I've been using R to gather the data. This initial information comes from a talk that I gave to more of like an enthusiast programming crowd last year. Basically understanding how much energy we get from the sun. And so there's this kind of general estimate that the sun gives us enough primary energy in 1 hour to power all of humanity's needs for a year. But of course, that there's a geographical variation with that. If I could go on to the next slide, and I have some very helpful, I hope, images. One of them, the one on the right, which I think is maybe more important than this, also cuts to where I think the NASA power data is very valuable, is that we've been able to model output from tilted panels by looking at diffuse DNR and also reflected solar radiation. One of the applications that the research group that I work with in Utrecht is very interested in is looking at the output from solar panels in snow-covered areas. Although Utrecht itself isn't very snow-covered, places like, say, for example, Alberta might be. And understanding albedo and how albedo impacts the output from solar panels is a valuable thing that we get from NASA power. If I could ask to go to the next slide. I'm just going to skip over this slide, actually, if I may ask, simply because, again, like I think I underestimated the level of the talks. Some of the things that I absolutely love about NASA power, first of all, that it's free. I started using it when I was doing my master's degree, and I think it would have been difficult for me to convince someone to pay for it. And the fact that it has hourly resolution, temporal resolution. So obviously, if you're running, if you're looking at a utility scale solar project, then you are in fact interested in even more finely tuned times. But we found that for the kind of academic work that we've been doing, it's perfectly fine to start with hourly data. And I also appreciate the availability of things like humidity. Humidity in general is not associated with solar power output. However, there is a growing trend to look at the apparent temperature and use that as an input to, or the heat index as it's otherwise called in the US, to use that as an input for modeling the temperature of PV modules, which then impacts the efficiency of the solar panels. And having that data available from NASA Power has actually been a help to us. I already mentioned the NASA Power package and the R repository. My preferred workflow is to use NASA Power through the R package, NASA Power, which is independent of you guys, and then to process that using Python's PVlib for the modeling. If I can ask to go to the next slide, that's okay. And so these are some funky photos that I had, and I apologize here again. I don't know if you can increase the resolution, but on the left, I'm showing the relationship that I get for a year's worth of data. This is for a site in Qatar that we were looking at, which is roughly latitude 25, longitude 51 east. And I'm showing the interplay the between hourly ambient temperatures and then PV cell temperatures on the left, and then on the right between the cell temperature, the PV cell temperature, and efficiency of the cells. And I believe I sent one final thing by email. Is that possible? Or no?
Fortunately, no. You'll have to move, use what you have here.
Okay, that's no problem. So I just wanted to a recent paper that we had published in July was looking at was relying on NASA power data. It was and one of the main advantages of this power set, of this data set, is that it allows us to look also at offshore sites. So the part of the research group that we're looking at is also interested in the relationship between offshore and inland sites, and we've been able to get what we think are some valuable insights into how building offshore renewable energy installations, the feasibility of that or the desirability of that varies across geographies. And so we've been in our recent paper that we published, we looked at the interplay between the performance of solar panels and the relationship between that and the Köppen-Geiger climate classification. And so that was, with that, I was going to end and say thanks to everyone for attending. I've been blown away by the level of the other talks, and I hope you all have a very nice day. And thank you so much to the NASA Power team. You guys are great. I love the also the responsiveness that you have by email.
All right, thank you. Yeah, appreciate the talk. So